Lowest average kinetic energy. The answer is whatever. Go ahead, Steph.
4.
Why 4?
Because the temperature is the average kinetic energy.
Right, so the definition of the word temperature is the measure of the average kinetic energy of a system. So the average kinetic energy tells us the temperature. So the lowest average kinetic energy would be the lowest temperature, number 4, very good. What does the 10 grams, 20 grams, 30 grams, and 40 grams have to do with this? No, absolutely nothing. Why do they give it to us? Confuse you, okay? You're probably used to this maybe in other classes, other regents exams. Chemistry is the same. They will give you information you do not need, okay? The mass of it has nothing to do with it. The temperature has everything to do with it. In other words, you can have a lot of water or a little bit of water, but they could have the same temperature, right? The amount of water doesn't change the temperature. So the amount of some matter doesn't change the temperature. So lowest kinetic energy would be 15. The particles are moving pretty slow. 45 would be, if they ask the highest, right, it would be 45 because that means particles are moving faster. Questions on that? Yeah.
Can I weapon?
Hold on.
Yeah.
Let me check this out here. Yeah, I think you got some time.
Okay.
Real quick.
We're gonna watch that video today, just real quick.
What video?
You said we were gonna watch it.
Yeah, there's 2 videos I gotta share. First, let's go over the homework. So I'm gonna leave that up. Let's go over the homework, and then we will do a demo back there, and then we will go over the notes from yesterday and watch the video. All right, 451. Here we go. 451. All right, number 14. Taylor, go ahead.
Don't really know.
Give me one relationship that you know. So between pressure, temperature, and volume, that's the PTV piece of paper thing, like the graphs. So give me one that you know. Maybe we.
Does it mean like I wrote down pressure is inversely proportional to volume?
Perfect. That's good. Very good. You do know. Good job. Pressure is inversely related to volume, right? So this is our temperature volume graph. If we were to do a volume and pressure graph, it would be indirect. As pressure goes up, volume goes down. That was the point of this piece of paper. Pressure goes up, volume goes down, and then vice versa. Volume goes up, pressure goes down. It's inverse. Good job. Okay, what about pressure and temperature, Sarah? They both go up, right. So if we had another graph here, temperature and pressure, that's direct. And then this one we already talked about today. Temperature, volume, they both go up. Temperature, pressure, they both go up. Basically, if temperature is involved, everybody's going up, right? Goes up, or down, down, and down, however you want to look at it. But when temperature is not involved, it's pressure and volume, it's inverse. It's inverse. And that was the whole point of this. All right, 15. We just answered that. I know that some of these questions were redundant, but I really want you to understand the relationships. So volume and temp, pressure and temp are directly related. Whatever one does, the other one does the same. Pressure and volume's inversely related or indirectly. They're opposites. Pressure goes up, volume goes down. 17. Infer why gases such as the oxygen used at hospitals are compressed. Why must compressed gases be shielded from high temps? What must happen to compress oxygen before it can be inhaled? Anybody? How about Edwin? Why are gases such as oxygen compressed?
I'm not sure.
That's fair. Well, what? You ever seen an oxygen tank?
Yeah, yeah.
Okay, why are they stored in them? Not something else. Why is oxygen stored in that?
Keep it pure oxygen.
Keep it pure oxygen, good. What do we use those tanks for? To give people oxygen, right. Now, my grandmother has a whole bunch of those tanks at her house, and she can bring them with her when she goes to the store or whatever. She has big ones. They're kind of almost the size of this table, like the height, and they're kind of thick. So usually she's not going anywhere by herself anyway. So if I bring her somewhere, we put the tank in the little cart thing, wheel it out, put it in the car, take it out, wheel it around. The point is, if the oxygen wasn't in a tank, she couldn't use it. So why are they in tanks?
Because more concentrated.
Why do we put? How come we don't keep oxygen in a container the size of this desk?
Because it's too big.
Right. Yeah, I'm gonna carry this around Walmart. My grandmother walks around. Right. I'm not gonna follow her carrying that thing on my shoulder. So it's for portability, right? So people can take oxygen with them where they go. That's why they're stored in tanks. Also, if you compress it, there's oxygen tanks not too much bigger than this. You can get small ones, but it has a lot of oxygen in it because it's so compressed. So not only is it easy to carry around, but you can get a lot of oxygen in there so you can use it for a lot longer. If we stored oxygen in big containers, one, there's no room, no store where you're going to keep something. The size of this desk, I mean, hospitals wouldn't really have too many of these. There's not enough room. So that's another thing. But also you can get a lot of oxygen out of just a little area because it's compressed. Hopefully that makes some sense. How come, let's say this is filled with oxygen, I'm not going to keep it near any source of heat. Shelby. Right, it'll expand, right, when it gets hot. Right, we just talked about that, and it'll explode. Good. And the last thing, what must happen to compress oxygen before it can be inhaled? Now, if you've seen these oxygen tanks that some people use, you have to screw something on the side. It's like a little, almost like a little cylinder itself, and it regulates the oxygen flow out of this thing. It essentially takes the compressed oxygen and then lets it expand so that when it enters your body, it's not compressed. Why would it be bad to inhale compressed oxygen?
Because then your lungs would be filled with it.
Well, what happens to compressed air or oxygen when it's not in something rigid? It expands. So if you inhale compressed oxygen, what is it going to do inside of you?
Your lungs are
It could blow up your lungs, right? Basically
crazy.
explode your insides. Okay? It sounds absolutely terrible. So that's why we don't breathe in compressed air. We have to let it regulate. Okay? I'm going to stop there. We're going to come back to that. Let's do the demo. It's ready to go. Grab glasses. Meet me over here.
Hey guys.
Let's go.
How do you know if the air is compressed though?
Yeah.
It's in a container.